The data highway blueprint, architecting modern internet communication, logical addressing error detection, flow control. Networks begin as a geometric representation of our digital nodes. Effectiveness is governed by precise delivery, accuracy, timeless, and in the absence of jitter, mesh topologies, high fault tolerance, maximum writing complexity, star topology, centralized hub routing, single point of failure, bus topology, shared central backbones with targeted drop lines. The Open System Interconnection Framework, a layered architecture standardizing communication across disparate system endpoint, process all 7 layers, intermediately routes only process up to layer 7. Layer 1 physical, layer 2 data link, layer 3 network, layer 4 transport, layer 5 session, layer 6 presentation, layer 7 application. Data link, error detection, MAC, SCRC network, logical addressing, AP4 transport, flow control, ARQ. The 32-bit logical layer, IP4 addresses allocate exactly 32 bits divided into network IDs and host ID, accommodating approx 4 billion unique digital logical addresses. Early IP allocation relied on rigid predefined boundaries, leading to massive inefficiency when organizations do not exactly match the class tier. Class A 08 NID, 24 ID, 126 net over 16 million hosts. Class B leading bits 10, 16 ID, 16 HID, 16K network, 65K host. Class C 110, 24 NID, 8 HID, 2 million networks, 254 host. Class A allocation. Wasted IP block, the rigid allocation problem. Precision subnet allocation 0 best. Classless inter-domain routing removes rigid classes by borrowing bits from the host ID. Networks are segmented into exact custom-sized logical partition. Network and subnet ID expanded, host ID contracted. /notion/26 subnet mask 25.25.225.190 available. Host 2 to the power 6 minus 2 is equal to 62 host. Reserved logic, a reference matrix of restricted IP4 configuration that cannot be assigned to standard host interfaces. Default route DHCP client used when a host does not yet know its IP addresses, reserved strictly for the self-connectivity, testing, and inter-process communication. Transmit to all hosts present entirely within the sender's local network. Transmits from a local host to all hosts residing in a specific external remote network. The threat of noise, corruption on the wire, noise disrupts bit synchronization, error detection relies on appended redundancy mathematically verified against the severity of the corruption, single bit error, flipped bit, burst error, burst length, Hamming distance IP to detect KRS D is equal to K plus 1 to correct KRS D is equal to 2K plus 1. The error detection arsenal, comparing the primary mathematical mechanism used to inject redundancy and verify payload structure. Protocol method, simple parity, appends 1 bit to enforce even and odd total of 1. Single bit detection, yes. Fails entirely or even numbers bit flips. 2D parity, matrix grid calculating parity for intersecting rows and columns. Single bit detection, yes. Burst error detection deducts 2-3 bits, fails on 4-bit rectangular corner. Checksum, segments data, adds blocks via 1 complement, appends inverted sum. Single bit deduction, yes. High deduction capability, low rate. Cyclic redundancy check, appends the remainder of the module to polynomial division. Single bit deduction, yes. Deducts virtually all burst error with extreme reliability. Pinpointing and divising, mechanism of parity and 2D parity matrix. Row plus column parity, pinpoints execute for corrections. CRC module 2 pipeline data k bits plus appended 0k minus 1. Module 2 division XOR, divisor polynomial key, quiescent discarded reminder data k CRC bits appends to payload. The anatomy of a network delay, data travel as a mechanical process. Bandwidth dictates insertion rate, velocity dictates travel speed, nodes detects holding time. L by B, message length, when time required to push bits into a physical transmission delay, propagation delay, D by distance by velocity, time required for the signal to travel the physical distance, queuing delay, buffer wait time, processing delay, header inspection, and a CRC check. Automatic repeat request protocol, engineering solution for flow load balancing, implementation complexity against bandwidth utilization, stop and await, sender window, receiver window, retransmission, single lost packet, bandwidth utilization very low, waits for acknowledgement, go back and sender window in. Receiver window 1, retransmission entire window from the point of the lost packet, bandwidth utilization high, pipeline data, selective repeat, sender window end, receiver window end, retransmission strictly the specific lost packet, bandwidth utilization maximum, requirement needs sorting buffer at receiver, stop and await mechanics, deadlock and duplicates, resolving mechanical failure using a timeout, timers and a sequence number, sender data 0, receiver acknowledgement 1, lost data day 1. data 1, retransmit, acknowledge 0, delayed, acknowledge data 0, acknowledge 1, data timeout, timer expires, timer expires, duplicate, discarded, relies on sequence, efficiency is equal to 1 by 1 plus 2, where A is equal to propagation delay, slash by transmission delay. Synthesis, the life of a packet. Logical addressing routes the data, redundant bits armor it against noise, and flow control ensures synchronized delivery. Stage 1, the ledger. Stage 2 is the armor. Stage 3 is the highway. Stage 4 is the acknowledgement. Yeah, thank you.